You think that it's just a bad headache, but when you go to the doctor's office, they tell you that they found a tumor in your brain. You've been diagnosed with glioblastoma, the most common and aggressive type of cancer that begins in the brain. Over 90% of all glioblastoma patients will experience a return of the tumor after surgery and chemotherapy, and half of all patients will die within 15 months of diagnosis. One reason that glioblastoma treatment usually fails is that it's extremely difficult to deliver drugs to the brain. Normally, when you take drugs, they travel through your bloodstream and then leave blood vessels to enter specific areas in your body. However, drugs can't freely enter the brain because of something known as the blood-brain barrier. The blood-brain barrier is made of tightly packed cells and acts like a fence between the circulating blood and the brain. This means that the brain is well protected against harmful toxins, but it also means that most molecules can't enter. My research is focused on finding more effective ways to deliver drugs to the brain. Specifically, I use nanoparticles to encapsulate drugs and transport them across the blood-brain barrier. This is much safer than directly injecting drugs into the brain. Nanoparticles are like tiny vehicles that can be up to 1,000 times smaller than a single human cell. The nanoparticles that I make are capable of opening gate-like structures on the blood-brain barrier to enter the brain. These gates are usually closed for most molecules. Once in the brain, my nanoparticles can release their drugs to target and kill tumor cells. Now, my nanoparticles aren't the only ones that can enter the brain, but they're unique in that they're made from a single plant-derived material that's never been used before to make nanoparticles. This makes my nanoparticles better than others for two main reasons. First, my nanoparticles don't need any modifications to get through the blood-brain barrier. Other nanoparticles need many modifications to achieve this. Second, my nanoparticles are extremely easy and cheap to make. Other nanoparticles are made from multiple materials, which makes them costly and complicated. The simplicity of my nanoparticles makes them ideal to deliver a variety of drugs to the brain. In mice with brain tumors, I've shown that mice that were treated by drugs delivered from my nanoparticles lived significantly longer than those treated by other methods. For the rest of my thesis, I plan to use my nanoparticles to treat other diseases in the brain, such as stroke. I believe that with my nanoparticles, we can greatly improve drug delivery to the brain and save people's lives. Thank you.